Next up, we're delighted to welcome Soumith Chintala. Soumith Chintala is a researcher at Facebook AI Research, where he works on high-performance deep learning. Soumith created PyTorch, a deep learning framework that has traction among researchers. Prior to joining Facebook, he worked at Musemi, where he built deep learning models for music and vision targeted at mobile devices. He holds a master's in CS from NYU and spent time in Jan LeCun's NYU lab building deep learning models for robotics, pedestrian detection, natural image OCR, depth images, among others. Soumith, over to you.
Hey everyone, my name is Soumith Chintala. I work at Facebook AI. I built this project called PyTorch with a bunch of other people together. And today I wanted to talk a little bit about open source projects, about how you build and think about open source projects, how to grow them. And I wanted to quickly give you a little bit of introduction to PyTorch, just so that you have enough context. So PyTorch is a project that is used by a lot of machine learning scientists and engineers to build their research and production workloads. So at the core of PyTorch, you have a tensor processing library with something called automatic differentiation, where you're able to take gradients of a particular mathematical formula, and you're able to adjust a certain system called a neural network using those gradients. And the entire ecosystem of PyTorch and its the peripheral packages around it are based on this particular core that we can call as PyTorch. And when we built PyTorch, we generally had a few principles, and these principles, we started with a certain set of principles, but we moved on to a certain other set of principles. And I think right now, what the principles we have are to always enable cutting edge research, and we want to be also make sure that the tension between cutting edge research and being production grade and being high performant are a good amount. There's a balance between them. That is, we don't want to just be a research tool or just a production tool. And we recognize that a large part of machine learning research right now is about wide exploration. That is, it's not just exploring the single vertical, but there's a breadth to it. So we want to be able to help exploration of different new ideas, while also help people take these ideas into production. So keep the exploration trade-off very much alive. And one of the other things that really factors into our thinking is, as PyTorch grew, we feel a responsibility of having more and more users. We have probably hundreds of thousands of users at this point, and we want to make sure we build the project with a certain thought, and make sure we don't do something that breaks someone's production while we're trying to trade off for the benefit of the researchers. So because there's this incredible depth and breadth to machine learning research right now, even though we're a big project, we're a big set of people across the world, we can't build everything ourselves. So primarily our philosophy has been to build the building blocks, and then figure out which bets we want to take on ourselves, and then co-develop the development of all the other tooling that is built on top of PyTorch with many stakeholders. And we think it's a natural way to regularize our thinking. That is, we might be wrong on many counts and many times, and if we are able to have that diversity of thought and many people co-developing and co-building PyTorch, we can get out of the problems we would have if we just stayed in our own bubble. And so we built PyTorch for the large part with an incredible set of collaborators within the machine learning and AI community, some of whose logos I've placed up here. And we also work very closely with the larger Python community. That is, outside of PyTorch, Python is huge in the data science ecosystem, if not the biggest ecosystem. And we work very closely to be interoperable with the rest of the Python ecosystem, which we recognize is much bigger and more powerful than us. And because of the general philosophies we've kept, but also because of various other reasons that I will talk about today, we've had a healthy amount of growth. We've, as of late 2020, which is when I pulled these numbers from, we've had about 1,600 plus contributors, 45,000 plus projects using PyTorch on GitHub, and about 34,000 users in our forums. And one of the things I will talk about today, but that I find very great, is even at this scale, 100% of the issues and pull requests that are filed on the PyTorch project get read by at least one PyTorch developer. And we built a lot of discipline into this, and it was not always the case, but it is true now. And PyTorch is not, I work at Facebook AI. PyTorch is heavily funded by Facebook AI, probably its largest funder. But PyTorch is actually co-developed at many different companies such as NVIDIA, Intel, Quantsite, Microsoft, AMD, IBM, Google, Preferred Networks, Amazon, and also like several hundreds of contributors who don't have a particular affiliation to a company or a university. And there's hundreds and thousands of projects built on PyTorch, and there are great high quality projects that we curate on our website that we generally call as the blessed PyTorch ecosystem. One of the things that we focused on for PyTorch was to try to enable research, and we've had a healthy amount of growth within the research ecosystem, where PyTorch has over time become the choice tool for machine learning research, and we're very happy and thankful to the community about it. And so that's the context of PyTorch, right? PyTorch is a product. It's a product that a lot of people use. That's the context. And I want to talk today about how we got here, the journey of PyTorch, and like I want to talk a little bit about open source. So most open source projects don't just get started with, oh, we need to have 100,000 users or something like that. That's not how people naturally align their personal interests. They kind of start with some personal interest. They say, oh, I want to do this thing and maybe publish my code out, and then someone else comes in and says, oh, that's interesting, that's something that I wanted to do as well, and maybe we can work together. And open source is fundamentally this organic, natural collaboration, right? So it's something that we do out of personal interest, and we try to intersect it. If we try to start a particular open source effort, then we also think, oh, I want to really do this thing, but I wonder if other people want to do the same thing. And in that case, should I maybe build out my code to also address some of the other things that other people want to do and make it a more general solution? So you kind of try to intersect your personal interest with that of the broader interest. And the market making here is a little bit of self-fulfilling prophecy, in that if there is enough broad interest on a particular topic, or that interest is growing over time, then the project or product that most addresses that interest grows over time, and people will commit time together to want to grow that interest. There are exceptions, such as open source as a large top-down mega corporation funded effort, but that's not really what I'm want to talk here today. So most small open source projects, after enough effort and involvement, they think about growth. They started somewhere, and then there's enough people attracted and interested in that direction, so they're happy about it, and they think, okay, like, this is great, like, what do we do to get another set of users and grow our community? And often, like, for an open source project, the community and the project are really hard to tease apart. So they wonder from a product perspective. They're like, if I ran this as a product with a company around it or something of that sort, how would I best sell, market, and grow my project? And in this note, I want to talk about 4 aspects you would generally want to think about when you're both building and growing an open source project. And I really talk about these things from the context of my journey from Torch to PyTorch and various other open source projects that I've been involved in my life here. So the first topic I want to talk about is the philosophy and principles. And we think about a project, I want to talk about how to define it. Like you can generally think of a technology-centric project, something like tensor comprehension that we built, where you care about a particular technical idea, and it's like your project is built around that technical idea becoming big. You think, oh, I think this technical idea is amazing, why don't more people use it? And that defines the identity of your project. And you can have another type of project, which is a user-centric project. You say, oh, I am a carpenter, and there are many carpenters in this world, and I would like to build the best tool for carpenters. And there you're thinking less about what particular idea or ideas you want to build into the project, but more from the perspective of a particular user who is using that project. And this is pretty common in product design. You think about like what kind of product you do. And I think like if you have clarity on whether you care about the technology or whether you care about a user-centric view, then you really can think about various decisions over time that would help you with especially the difficult decisions that help you with making those decisions in this framework. I started working with this project called Torch that is predating PyTorch and starting in 2010, 2011. Over time, I made friends in the Torch community. I understood the implicit principles they stood for, and I understood that they are a user-centric project. And like understanding various people's involvement in the project is somewhat very vague and very ill-defined, kind of like politics, where no one says anything directly, or no one's involvement is like based on a particular contract. It's just people are involved organically, come in and out of things, and various deals get made that are not always explicit. There might be just implicit or understood. Not everyone stands for the same thing. So over the years, I absorbed and appreciated that Torch was a user-centric product. And it stood for certain things. It stood for immediate mode, easy to debug, stay out of the way, explicit code. It was targeted at people somewhat familiar with programming matters and who could reason about things like performance if needed, or write a C function and bind it in quickly. So when we were writing PyTorch, I came to the realization that in an organic open source community, not everyone stands for the same principles. We had a couple of really important members in the Torch community who were against Python. So even though our user-centric view allowed us to go in that direction, we had they just didn't agree with it. So then we had to make a difficult decision of either bringing these critical people along or leaving them behind. And these decisions are difficult. They don't have a right answer. They're only subjective calls, but if you're clear on what you stand for, what are your principles and philosophy of the project, you can make them with a lot more clarity, and you can try to make the right decisions. In such scenarios, it's often worth thinking about when to stay strong and when to compromise. Like, my view is that you have to be absolutely stubborn on the principles and philosophy that you're driving, but everything else is changeable. And this view was really useful in bringing people along over time. PyTorch brought along and integrated the Cafe2 community and the Chainer community into the PyTorch ecosystem, and stayed really friendly with the JAX and the Swift for TensorFlow communities. Since their inception, we always discussed various ideas and brainstormed things with them. And I think like bringing others along has a huge advantage. The community gets bigger, you arguably get wider perspectives, and they make the project better over time and better and broader over time. And as long as you're stubborn on your core principles, you aren't really compromising on your original vision. You're only strictly making it better. And so, like, leading into this, I want to talk about another topic, which is the scope of the project and the risks, how to quantify or think about the various risks you take of the project. So apart from the challenge of bringing the Torch community along, the second thing we were facing was our most formidable competitor at that time, which was TensorFlow, was rumored to have 10 to 30 times more developers than we had. We were very organically built. We were like a couple of people at Facebook and a couple of people at NVIDIA and a couple of people at, just within the Torch community, who we've grown friends and close over time. We built Torch and we maintained Torch, and that's who we were. And we would collaborate mostly online, nights and weekends, versus what we heard about TensorFlow at that time was it was 10 times bigger than us. And it depends on how you count, bigger than that. So the really good thing for us, though, was TensorFlow was trying to be everything for everyone. So from our visibility, it was a project planned top-down with a human amount of resources and breadth. And so we naturally tried to take the exact opposite approach, mostly to survive and compete on realistic terms. It was not like we had an alternative. We decided that we would concentrate on no one except ML researchers and make their particular experience really good. So we said, machine learning is a large space. There's different kind of personas. TensorFlow is going for everyone, and they have the resources to go and try to cater to everyone. We don't. So let's just pick one topic that we can try to excel and just make that, just be the best at it. So that way we can stay focused and deliver with lesser resources. So we intentionally scoped down and hence took more vertical risk but less horizontal risk. We just wanted to nail our addressable market. However, once we were successful in the market with PyTorch, we got incrementally ambitious. And I think this is like a very commonly used philosophy between individuals, personalities, and projects, and whether you're incrementally ambitious or whether you are visionary to begin with and just growing towards that vision. And we slowly and incrementally expanded our scope and ambition as we grew and matured. And this approach scaled well. Here, I also want to talk about the deliberate nature of risks you take and how it could shape your destiny. So we were making a deliberate bet on the ML researcher market, and that we thought of two things that need to be true for us to survive. One, that the ML researcher market, that is the modeling that they do over the next few years, would need more flexibility and debuggability, which is because that's the product we were building. And two, that the ML researcher market would continue their innovation cycle on crazier and larger and weirder model architectures, and that it would become the mainstream future. That is, the ML researchers, whatever they were producing, that it would become the production a few years later. And both of these were bets that actually could just fail, and we would be out of business, right? So with this bet, we needed a very wide API, because if you want ML researchers to have flexibility and debuggability in the framework they're using, to express all their ideas that they wanted. That's what we needed. So we needed a very wide API, but also at the same time combine that wide API surface with user experience that helped use and extend it very easily. And so like, I mean, I think about various ways in this we could have just failed because of things out of our control. So, for example, we could have just hypothetically stopped as a community, as an ML community, we could have stopped innovating at ResNets, no transformers, none of that, and maybe stopped innovating for a decade. And then, after a few years of stopping at ResNets, people would have figured out, oh, we don't need these wide surfaced APIs such as PyTorch and TensorFlow. Maybe we just need a more focused library for ResNets. And I talk about this in a previous talk I gave at Scaled ML. You can go check it out. Apart from scaling and risks, I want to talk about measurement and metrics. Apart from our core principles and scope, generally, and this is common in product development, we wanted a feedback loop with our customers. We wanted to know how they're doing, whether we're serving them well, and how we can improve and iterate on our product. And then we asked ourselves about how we want to track various dimensions of PyTorch. And this is, I think, very common problem in product, but also the problem that many people just get wrong. So we asked ourselves, are these metrics, are the aspects of PyTorch that we want to get feedback on, we wrote them down and we said, for each of them, are they measurable at all? Like, are they measurable at all? Or are they just like subjective things? Or are they measurable well? Like, you can measure something, but if you can't measure it well, then is it worth measuring? And then so we asked ourselves, should we measure certain aspects like these, or should we keep it in subjective land? And if you can't measure certain things, how do you deal with them at scale? And in our Torch days, we learned a lot about how people love to measure things and how others love to read comparisons of measurement as gospel. For example, people publish micro benchmarks, or people publish graphs of how a project grew by GitHub stars, or people draw tables of feature comparisons saying, oh, X is better than Y in this feature, but Y is better than X in this other feature. And people love to read these things. And during our days in Torch, some people published various measurements comparing Torch to other frameworks at that time. And we felt a bit wronged in that, and this is normal, in that like these measurements are done with someone else's perspective, probably a very narrow perspective, and they were not always very defensible. Like, we couldn't defend ourselves against those measurements because we didn't think those measurements give value to what we thought was valuable in Torch. So the bigger realization we took out of this was to ask ourselves how prematurely measuring something shapes your product in a bad way. Even though we didn't write blog posts measuring Torch to competitor, we were constantly expending a lot of energy to optimize for these measurements, as in we were reacting to make ourselves look good in these measurements. And then when we wrote PyTorch, we were clear on two things. On that one, that our core competency of usability and flexibility and debuggability is just not measurable. It's very subjective. It's not measurable like speed or performance or something like that. And second is that there's no good way to measure it, and we had to get really comfortable with this ambiguousness. Like, how do you drive large groups of teams of people working on the project if something like this is ambiguous and not measurable, right? It's still subjective. The second is we believe that if we don't react to external measurements of PyTorch, we can actually stay more focused on our project, and it creates more long-term value, even if it creates some short-term churn. So in PyTorch's history, we never responded to any speed benchmarks or measurements such as GitHub stars or We never submitted to industry benchmarks such as MLPerf ourselves as the PyTorch authors, and it's very deliberate. We're happy with our approach. We just said, like, if these measurements don't value what we think is the right thing, what our product puts things at the center, then why do we need to use these measurements at all? And that kind of worked. And like when someone, like, this is a common thing when I give a PyTorch talk, someone would ask, hey, how fast is PyTorch compared to X? And it's something that I can answer easily, but then our idea was that if we did, then we would basically be put in a defensible state. We would constantly be put in this position to answer these things which we didn't want to focus on. So I would just like sidestep the question. I'd be like, we are more flexible and probably within 10% of performance compared to X. Why don't you just try us out and take a call? And this gave us an incredible superpower to just focus on our core competency without the pressure of getting dragged into what we saw as a reductive view of our product, a view where our superiority was not valued at all. So the metrics we often relied on for PyTorch were whether PyTorch was actually used. So in GitHub's global code search, you can search for import torch, and then you can measure how many people actually imported PyTorch, or you can see in research papers how many people cited PyTorch, formally and officially. And we use some of these, but these are huge lagging metrics. That is, by the time people actually cite PyTorch in their paper, they've been working on that paper for 6 months. So it's a lagging metric. And so at a smaller scale, when we started, what we would do was for me to basically read the entire volume of information that was produced on the internet about PyTorch, from GitHub issues, forum posts, Slack messages, Twitter posts, Reddit, Hacker News, everything. Just read everything, and then prioritize our feature development or bug fixes based on a subjective understanding of what was going on. And this worked really well, but it didn't really scale up to after a point. And my last topic here is to talk about scaling your open source project. And this topic might not be of interest to everyone, because no one really goes to the scale of PyTorch or TensorFlow or projects like that. But I think it's useful for whoever has to deal with it. So as we scale, I think within 2 years of PyTorch, I was actually getting to physical and human limits of doing this every day. I was going through about 500 GitHub notifications, 50 plus forum posts, lots of Slack and Twitter activity. And I was working 15-hour days, and I was just exhausted all the time without doing much else. So I tried to figure out how to make a scalable approach to this without falling back onto things like measurement. And so my colleague, Edward Yang, who really is good at such things, he took over the process with the intent of first observing it and then building a better process to scale it. He wrote a fantastic blog post summarizing it that you can look on easyyang.com. And I'm not going to try to cover it fully, but the nice realization that I came to from watching him do this is that at a certain scale, you can't aim to please everyone. You can't aim to do everything for everyone, and it's okay to prioritize heavily. Just heavily prioritize on what you want to do and what you just cannot afford to do. And it doesn't make you cruel for not being able to close every GitHub issue. So I think the other thing I think you think about scale is you generally think about whether you want to be vertically integrated or if you want modularity. And this is generally hard. I think one classic example I read about was AMD and Apple are two opposites. AMD actually spun off their fab division into a separate company because their vertical integration wasn't working very well. But Apple, on the other hand, with their new M1 processors and the entire software hardware integration, is doing such an exceptional job at vertical integration that it's a superpower. So I think like at scale for your project, you need to figure out whether you want to keep your project into a single monorepo where everyone's collaborating and you vertically integrate and keep like lots of dependencies between each other, or you don't. And that really depends on the amount of bandwidth you have between people that are working on your project. And I think like that's really like what I wanted to cover. I really hope this was helpful. I try to cover through a few stories and through our journey on PyTorch and how we think about our open source efforts. And if you have any thoughts, feel free to drop me a message or an email. Thank you.